Today I'm going to demonstrate a AI spam checker that I made. It's actually a chatbot and a spam checker unified. How this works is on the front end we have a Blazor app that is running oops. Here we go. On the front end we have a Blazor app that's running our C# logic. Now this is actually the same logic that I used before. I did have to edit it some in order to encompass what we're doing, but there's nothing new from my previous video. On the back end, this is where everything is new. So we'll start by looking at the data that we began with. So what this data is we have a message, we have a bunch of text messages that were gathered, and some are, if they're labeled ham tab, that means they are good messages. If they're labeled the spam tab, then they are not good messages, they are spam messages. So in our data, go to our data processing in order to get it to a point where our BERT model is going to be able to read it. I had to take out any special characters, and then I had to take out any additional spacing, and I had to change all the text to lower, as well as I had to load a file path, or I had to create a function that's going to load the text into a file path and create a data set where each line from my file is going to be split on the tab. That way we're able to read which ones are spams, we're able to get a label of spam or ham, and then we're able to get the text. And then in our next function of preprocessed data set, this is where we're actually going to begin setting things. We're going to create a dictionary from our data set of this, where we loaded the file path into it. And we're going to create our labels of ham or spam, and then the text. And then down here we're actually going to be doing the I gotta remember what I did. Alright, this is just exemplifying. And then this is where we convert all that data to JSON, and we return it. Our file path is set here, and our this is where our preprocessed data lives. It gets sent to this file path, I should say. Now this part isn't actually important to be for functionality now, but it was just something I had to do along the way. Then we can go to our, I believe it's the train model. So this is where I actually trained the BERT model to be able to know what is spam messages and what isn't spam messages. How it works is we're going to have a different file where we load our preprocessed data. So what happened earlier is we read it into a JSON format in this file. There's about 5,000 lines. We're going to go through and we're going to split this into training sets. We're going to create a label map where ham is equal to 0 and spam is equal to 1. That way BERT can actually understand that, because computers obviously don't understand ham and spam, they understand numbers. So it's best to convert them to numbers so we can actually create labels. This is some label mapping. And coming down to our training arguments here, these are just a bunch of variables that are a bunch of values that I was recommended that were put in for training. Essentially, this is going to be looking at the temporary location results, and that's where it's going to be outputting this information to. And epoch means that we're going to iterate through our entire data set first, and then we're going to evaluate. Our learning rate, this part is actually a little bit above my understanding, but again, these values are recommended to me. We're going to go through 3 whole epochs, or 3 whole iterations of our data, so about 15,000 lines in total, since our original data size is about 5,000, to train this model. Now this did take a really long time on my computer. I was a little surprised at how much energy and time this took up. Our trainer, or we're going to create a trainer object, and that's going to that's just going to create a tokenized data set for train and testing. And then we're going to begin our trainer model, and we're going to save our models at the model at the temporary model HTTPS. come over to our app.py, and this is our actual, this is our UV-Corn app using Fast API. We're gonna create a client OpenAI with the API key. Mine I will paste in here in a second. Then I'll just go through and deactivate it. In fact, I can just do that now. And then I'll just deactivate this key afterwards, so that way it doesn't matter. We're gonna create a tokenizer that creates an auto tokenize from the pre-trained model from the HTTPS temporary address model, and then we're gonna make it call this thing called auto mode for sequence classification from pre-trained. Again, this is just some data or some formatting that I found on OpenStax to help get this thing going. And then I'm gonna initialize a Fast API app. I had to put some cores logic in here since we are communicating between two different ports. We're commuting on 8000 here, and then our other one works on port 54 something. Our Pydantic model, I set a way to validate the information to make sure it's coming in the way that we need it to. This is going to make sure this is going to classify our input text to make sure that it looks again like it's supposed to. And this was actually I guess the ultimate purpose of this is whatever text we input. So let's say I give BERT a spam message, it's going to be able to give me a number, and if that number isn't 1, or if that number is 1, then we get a ham. If it's anything else, we get a spam. And I'll demonstrate that a little bit later. Here we get into kind of the nitty-gritty of how this whole thing works, but this is where I've moved my my model logic from my front end to my back end to make sure that the BERT and the back end can communicate. We're going to create a class. We're going to create a class where we classify our input text, make sure, and again, we're just going to get a 1 or a 0 from that. And if the classification is ham, I guess we're going to get spam or ham from that. And if it is ham, then we're going to go ahead and create this request to our GPT server or from OpenAI. And in turn, we're going to return these values. If it is not the case, then we still want the input text that we gave. We still want the classification, but it's automatically going to say this message is classified as spam. We're not even going to try to reach the OpenAI server, so we don't get any accidentally wasted tokens. Coming to our front end, the Blazor app, so this isn't nothing really new here. This is honestly all the same from last time, with the exception once we get to our actual code down here. This is just a testing function I made. It's not really that important. I had to change my post-sync or my HTTP request to the new temporary HTTP address instead of requesting directly from OpenAI. Just if there's anything really worth pointing out. This is something important, I'd say. We have a bunch of conditional logic to first we had checked to make sure if our predicted class, or if it even gave us a predicted class, kind of as an indicator as to whether or not our backend is working, because it should always give us a predicted class ham or spam. If it doesn't, then we're going to skip down. This is essentially saying our model isn't working. Here we're going to start adding to our messages just like we did before. We have a list of messages, which is accessed up above. And if it does work, then we're going to get, or if we're inside this, then we're going to get a response from OpenAI. And or if it doesn't, if it's not ham and we somehow made it this far, we're just going to get this message is classified as spam. And now we'll show you how it works. Oops. So you can see just general functionality for the chat still works. And it's going to run the logic. Gets a good response from OpenAI, but I'm going to copy and paste just a typical sales text I would get. This one's from Shoe Carnival, and we'll see what it says. This message is classified as spam. So that was actually from the BERT server, not even from OpenAI. That's what the whole point of this was. Kind of a redundant, really, or a redundant functionality, truly, because OpenAI themselves could probably solve this problem. This is really just more of a test to see, first of all, could I even do this? Do I have the capacity? Turns out, yes. I can't say I fully understand every single thing that happened there that I was working on. A lot of it was recommendations made to me from different sources, but overall, I did have to do a lot of troubleshooting and really get into the details of what was going on and try a bunch of different things until I got it to work.